Okay, so here are another example of where quadratics can help us solve interesting problems using some of the same concept we used with the square root problem. So the most basic one of these, and that we're going to show a connection to the square root problem as well. But the most basic one of these is if you have 1 over 1 plus 1 over 1 plus 1 over 1 plus, and what you end up with is what we refer to as a continued fraction, where this fraction just continues in the pattern that I've shown to infinity. And we're going to use the same idea that we used in the square roots, which is this is because it goes on to infinity. If we take away essentially one of the steps, it has the exact same value because it goes to infinity. So we solve this in the same way. We want to know the value of this. So we say, okay, I need to know what x is if I let that equal x. Well, the way that it's solved is to recognize that this is the same as the original fraction. So if that is the same as the original fraction, then I can just rewrite it as 1 over 1 plus x equals x. Now I've taken a very complicated onto infinity problem and I've made it not complicated and not onto infinity. And so I can now solve this using what I know about quadratics, which is to multiply both sides by 1 plus x. That gives me 1 equals x plus x squared. And so that means x squared plus x minus 1 equals 0. And so when you solve this using quadratic formula, you'd get x is going to equal negative b. And so negative 1 plus or minus the square root of b squared, which is 1 minus 4 times 1 for a times negative 1 all over 2. So that gives you negative 1 plus or minus the square root of, well, this turns out to just be 5. So negative 1 plus or minus square root of 5 all over 2. It can't be negative again. This is positive, and so the negative value is not going to work. So that means x equals negative 1 plus the square root of 5 all over 2. And so the value of this is negative 1 plus the square root of 5 all over 2. So, and if you notice, this is something that's very close to the golden ratio. It's not exactly the golden ratio, but occasionally we can come up with other ways that the golden ratio that would show up in problems. Okay, another example of this would be one that looks like this. And that would be you kind of start the same way, except that you have 1 over, but instead of having all ones, this time we're going to throw a 2 in there. But you approach it just the exact same way in that we let this whole thing equal x, and we notice that this is the same as the original thing we were trying to find the value of. And so now we can just do 1 over 2 plus x equals x. Again, we go through and we multiply both sides by 2 plus x, and we get 1 equals x times 2 plus x. So 1 equals 2x plus x squared. That gives you x squared plus 2x minus 1. Apply the quadratic formula. So x equals negative 2 plus or minus square root of b squared, which would be 4, minus 1 minus times negative 1 all over 2, which gives us negative 2 plus or minus the square root of 8 over 2, which actually simplifies nicely to negative 2. We're going to do just the plus again because we know that's a positive value. 8 square root of 8 is 2 root 2. And so our 2's can all cancel out, and we get negative 1 plus root 2. And so this continued fraction, 1 over 2 plus 1 over 2 plus 1 over 2 plus 1, has the simple value of negative 1 plus the square root of 2.